Hello again. Okay, so we're going to continue on with page 7 from our packet. Now, we already did the examples on the top of this page up here, numbers 10 and 11 in the last video. So we're going to talk about numbers 12, 13, and 14 on this page. Now, if you recall, okay, this right here is the setup of a sine or a cosine function. For now, we're going to learn it gets a little bit more involved, but the number in front of the word sine or cosine is your amplitude, which is the height from the midline of the graph, and the number in front of the x is your frequency, which is the number of complete cycles between 0 and 2 pi. Now, I also showed down here, this is the behavior of a sine curve, right? It starts off at the midline, starts off and ends off on the midline. Whereas your cosine curve starts off at the max and ends off at the max, okay? Now, let's take a look at each of those curves. If we look at number 12, we could see this right here. This looks like our sine curve, okay? And because it's going up to a maximum first, this is going to be a positive sine curve. I'm just going to write this down. These are my notes, okay? This is a positive sine curve. Okay, now, we know that within an equation, we have to know the amplitude and the frequency. So here, the amplitude, if this is the middle height of our graph, it's how high the graph is going from the midline. So if you follow that over, it's going to a height of 30. So the amplitude equals 30. Okay, now the frequency is the number of complete cycles between 0 and 2 pi. But this is the problem. The x-axis is not labeled in terms of pi. So I don't think we're going to be able to use our definition and just look at the graph and say, oh, here's my frequency, it's 2. What we're going to have to do is we're going to have to use that formula that we learned about. The frequency is equal to 2 pi over the period. Okay, so 2 pi over, well, the period is the horizontal length of one complete cycle. This right here is one complete sine curve. So how long does it take us along the horizontal axis to complete that sine curve? Well, my eyes are really bad, but I think that says a 32. So it takes us 32 units to complete this sine curve. So that's our period. I'm going to replace the word period with a 32. Okay, and then we could just take this and simplify it. So you're going to leave it in terms of pi, but 2 over 32 would simplify to 1 over 16. So it leaves us with 1 pi over 16, which I'm just going to write as pi over 16. Okay, so all we're going to do then is we're going to take this amplitude and substitute it into our equation in front of the word sine, and we're going to take this frequency and substitute it into our equation in front of the x. So we could rewrite this as y equals, don't forget that, the y equals, it has to be an equation, y equals positive 30, and again, it's a sine curve, and then we're going to put the frequency, which is pi over 16, in front of the x. I'm going to put that in parentheses. You don't have to, though. And this is our equation. Now, if you look back on the examples we completed in the last video, what you'll notice is that we always had a number here in front of the x. We had a number for our frequency. Whenever your x-axis is in terms of pi, you will have a number in front of your x. But see how here, how our x-axis is not in terms of pi? When our x-axis is just numbered, that's when you're going to have a pi as your frequency. Okay, so I honestly think you could do all of the examples on these on pages 7 and 8. So why don't you try out 13 through 17 on your own, and hopefully you'll get them. Okay, so when we look at number 13, you could see this is a cosine curve, and it's a positive cosine curve because it's starting off high and ending off high. So I'm going to write this just in my notes as a positive cosine curve. So this would be considered like your work. Okay, now the amplitude is just how high the curve goes from the middle height of the graph. So the middle height of the graph is right here at 0. It looks like our curve goes up to a height of 3. So the amplitude is 3. And then the frequency, well, since the x-axis is in terms of numbers instead of pi, we know we're going to have to use this formula right here. The frequency is equal to 2 pi over the period. I'm just going to work my way down here. So 2 pi over, well, the period is how long it takes to complete one cycle. So this cosine curve takes us, this is how long it takes to complete one cycle. So it takes us to 320 units. Okay, so I'm going to replace the period with 320. All right, and then all you have to do is simplify. You're going to leave it in terms of pi, so we're going to simplify the 2 over 320, which would be 1 over 160. So this is going to be 1 pi over 160, which I'm going to rewrite as pi over 160. Okay, so now we know the frequency, the amplitude, and then we have a positive cosine curve. So let's write our equation. Y equals, all right, positive 3 times cosine of, and let's put this frequency in front of the x. So pi over 160 x. Okay, and there is your answer. And if you want to insert parentheses there, you can, and if you don't, that's your choice. All right, so number 14, if we look here, this, it's starting at the midline. So if it starts at the midline, it's going to be a sine curve. Okay, see how sine curve starts at the midline? Now the difference between this and our basic sine curve, the basic sine curve starts off by going up to the maximum. This one is going down to the minimum first. So what that tells us is that we have a negative sine curve. Okay, so our amplitude, we can see, right, this goes from the midline, it goes up to a height of 300. So our amplitude is 300. And then finally, the last thing we need to make an equation is the frequency. So because our x-axis is in terms of numbers, I mean, technically you could always use this formula if you want. The frequency is equal to 2 pi over the period. So that's going to be equal to 2 pi over. Now be careful. I know our picture ends right here at 32, but the period is how long it takes to complete one cycle. This, from here to here, is one complete sine curve. Okay, I'm going to actually just kind of trace it out. This is one cycle. So this number in here is going to be our period. So our period is 16. Okay, it's not 32. That's where we would be if we did 2 cycles. Period is how long it takes to complete one cycle. Okay, so we're going to replace the period with a 16. And then since 2 over 16 simplifies to 1/8, that leaves us with 1 pi over 8, which is just pi over 8. All right, and from this point, do not forget to write your equation. Your equation is going to be y equals, this is a negative sine curve, so negative 300 sine of, and then let's just put our frequency in front of the x. So pi over 8 x. Okay, and I usually like to put the parentheses, but like I said before, that's your choice. Okay, so this is going to be very repetitive. So now we're going to take a look at the last 3 examples, which are on page 8, and we're going to, just use this to help us over here. Now this, we could see this, since it's starting at a minimum. Okay, anything that starts at a maximum or a minimum is going to be a cosine curve. All right, and since it's starting at a minimum, this is going to be a negative cosine curve. All right, so then our amplitude is how high the graph goes from the middle height of the graph. So the middle height of the graph is the x-axis. So from there, we're going up to a height of 40. So the amplitude is 40. Okay, now the frequency, we know that when the x-axis is in terms of numbers, we're going to have to use our formula. Frequency equals 2 pi over the period. Okay, so the frequency is going to be equal to 2 pi over, well, the period is how long it takes to complete one cycle. And this is one, basically, flipped cosine cycle. This is one cycle. So it takes 32 units to get there. So I'm going to replace period with 32. Okay, and then since 2 over 32 simplifies to 1/16, this can simplify to 1 pi over 16, which I don't like to write the 1. I'm going to write as pi over 16. If you put the 1, it wouldn't be wrong, but usually it's preferred not to write it. Okay, so then our equation, we don't want to forget about that, would be y equals, so we have a negative curve, so it's going to be negative 40 times cosine of, and let's put the frequency, which is pi over 16, in front of the x. So there is our equation. And again, I just want to point out this negative just tells us that our curve is starting, if it's cosine, at a negative, at a minimum, instead of a maximum, okay? If one of the questions said, what is the amplitude is positive 40. Amplitude has to be a positive number. All right, let's take a look at the next one, number 16. We're going to do the same exact thing. Okay, so number 16, we could see it's starting on the midline, at the middle height of the graph. So that's telling us this is going to be sine. And since it's going up first, it's going to be a positive sine curve. Okay, now the amplitude is same as it's been this whole video, the height from the midline. So the amplitude is going to be, from this midline, we're going up to a height of 60. So the amplitude is going to be 60. Okay, and then the frequency, since we have our x-axis, in terms of numbers, we're going to have to use our formula. The frequency is equal to 2 pi over the period. Okay, now, please do not plug in 160 for the period. The period is how long it takes to complete one cycle. Isn't this right here one complete sine cycle? Okay, once we reach 40, we've completed the cycle. So for period, we're going to substitute that with 40. All right, and then since 2 over 40 simplifies to 1 over 20, this simplifies to 1 pi over 20, or just pi over 20. Okay, so now for the important part, we don't want to forget to write our equation, because that's what the question's asking, right? To write an equation. So y equals, and this is a positive sine curve, so it's going to be positive 60. And then sine the frequency times x. So our frequency is pi over 20. So pi over 20 times x. And there we go. Okay, and then the last one, number 17, let me slide that up. All right, let's do the same thing. Now, here, we're actually going to the left of the y-axis, but that's okay. I'm just going to look at what's happening as we go to the right. So we're starting off at the height of the midline, and then we're going up. So isn't that what happens with our sine curve? So this is a positive sine curve. Okay, now let's see the amplitude. Well, the amplitude, it goes up to positive 1, so the amplitude is 1. And the frequency, since our x-axis is in terms of numbers, right? We're going to use our formula. Frequency equals 2 pi over the period. All right, so that's going to be equal to 2 pi over, well, the period, let's see, from here to here, isn't that just half of the sine curve? So it takes us 1/3 units to get half of the sine curve. If you wanted to grab the other half of the sine curve, 1/3 plus another 1/3, right? 1/3 plus 1/3 is 2/3. It would take us 2/3 units to graph the entire sine cycle. So the period would be 2/3. Okay, now from here you could do one of two things. You could take the easy route and just plug in your calculator 2 divided by 2/3. Okay, and see what you get. Or remember, if you have a fraction within a fraction, we can multiply the top and bottom by the reciprocal of the denominator. So the reciprocal of 2/3 would be 3/2. All right, and the reason we do that is because on the bottom, look, 2/3 times 3/2, these are going to cancel each other out. The 3 on the top cancels with the 3 on the bottom. The 2 on the top cancels with the 2 on the bottom. And that's just going to leave us with our numerator. I'm going to rewrite that down here. So the numerator says 2 pi times 3/2. So let me just put that 2 pi over 1. All right, now let's see what happens here. We have a 2 in the numerator and a 2 in the denominator. So these 2's are going to cancel. And it leaves us with pi times 3 is 3 pi over 1, which is just 3 pi. So our frequency, I'll just bring that word down. You don't have to. This equal sign implies that whatever is to the left of it is what you had to the left up here. But if you want to bring the word frequency down, the frequency is equal to 3 pi. So now let's make our equation. So we'll have y equals, all right, it's a positive sine curve, so positive 1. You don't have to put the 1 in front of the word sine. If you don't want to just write sine, it's implied that there's a 1 in front. So y equals sine of, and let's see, our frequency is 3 pi, so we're going to put that in front of the x. And then there you go, that's it. This is the equation of this graph.